All right, hi guys. This is going to be how we are going to do geometry notes. So you'll notice I'm filling out the exact same note packet that you guys have. The reason for this is I want to make sure, number one, we have proper definitions. But number two, let's be honest, drawing a hexagon on your own is just a recipe for disaster. So this entire year we'll do printed notes so that way you don't have to worry about any of the images. But to get started with geometry, we need to actually set up some definitions. So the first definition we have is a point, and a point is simply a location. It has absolutely no size or shape. It is simply telling you where to go. So when we write points, we always use capital letters, and the main reason for that is sometimes your guys' A's look a little like O's when they are not capitalized. So this just kind of eliminates any sort of issue we might have with what are we seeing, where are we seeing it. All right. Now a line is made up of 2 points, because through any 2 points we can create a single line. All right. A line has absolutely no thickness or width. All right, and to name a line, you're going to use any 2 points on the line, or you can use lowercase script letters, and that's just kind of fancy ways of writing it. So you could write it as capital X, capital Y, and put the symbol on top. Now that symbol tells us it keeps going in both directions forever and ever and ever. All right, you could also write it with line N. And here is that little N that they're using to identify. All right, you could also use fancy cursive and go line XY, but let's be honest, we're all just gonna go for this. It's the easiest, it's simple, and we all know what we're talking about. Now the next 2 definitions are collinear and non-collinear. So collinear means that they are on the same line. So X and Y are both collinear because they are on line N. Now, if I add some random dot, let's call it G over here, that is now a non-collinear point because G is not on the same line as X and Y. All right? A plane is a flat surface that's made up of points. Now, the problem with trying to do a flat surface on top of a flat surface is it kind of just looks like a parallelogram. All right, so it's really difficult to try and draw 3D shapes on a 2-dimensional piece of paper, hence why I gave you guys stuff printed out, so that way you're not trying, well, how should I make this look? This way you've already got it. All right, so on a plane, it takes 3 points to make up a plane, not just 2. All right, 2 form a line, 3 form a plane. All right, it extends indefinitely in all directions. So think in terms of like this lovely fake brick wall in my basement. All right, if this were considered a plane, it would keep going in both directions forever and ever and ever. All right, so on this one, it says name a plane with any 3 non-collinear points and a script or an uppercase script letter. So you see this little fancy script letter? You could name this as plane P and call it a day. You can also name it plane K, J, L. And the order of these 3 don't really matter. All right, so coplanar points, again, coplanar, collinear. Notice that prefix at the beginning, that tells you quite a bit. All right, so coplanar means that they are on the same plane. Non-coplanar means they are not on the same plane. All right, typically you're looking for a 4th point. That 4th point is outside of the plane. All right, so now we are going to look at what happens when they intersect. All right, so when 2 lines intersect, it creates a point. It is a single location. Now, when we're looking at a plane, think 2 pieces of paper intersecting each other. This creates a line. All right, think of it the same way, again, with the basement example. Wall meets with floor, creates that line down at the bottom, and hopefully you guys don't hear my air conditioning kick on, but we'll find out if you do. All right, so for the next page, we're going to be looking for very specific sets of things that match the criteria that I'm giving you. So part A on number 1 says 4 collinear points. So I need 4 points that are all on the same line. So if you look over here, I've got 2 over here. So on line P, I have O, N, and M. On line Q, I have L, K, and J. And on line R, this is the only one that actually has 4 dots. So it is H, N, K, and I. Now, when you guys do this, I typically like putting commas in between them just because it kind of makes it look a little neater. You could just put really large spaces. It's whatever you choose. All right. Part B, a line that contains point M. So if you look, here is M. All right. We can either say line P, or we could say M-O and draw arrows. You could also say N-O with the same symbol. And the reason for that is because these 2 points create a line and then eventually it hits M. It's, again, preference. All right. C, a line that contains H and K. So again, we're down to line R. And I'm just going to kind of use line P and line R for right now because I feel like it ends up being too much of an alphabet soup. So I want to simplify just a little bit while I can. All right. D, name another line for line Q. All right, so we could say JK with arrows. We could say KL with arrows. And we could say JL with arrows. Either of those 3 options would work. The last part for this we have is part E, and that says the intersection of lines P and R. So line P, let me erase all of my doodles on the picture. Line P is right here, and line R is right here. Now you'll notice they intersect at point N. So that's all I'm going to write right here. And that is it for the first section. Number 2, use the diagram to the right to name the following. All right, so what is a line that contains point F? Now if you look, point F is over here. And if we want to stick with our little fancy subscripts, then the ones we're going to be using as subscripts are J, K, and M. All right, so a line containing point F, let's just call that line J, because that's what it's on, and that way we don't have multiple answers popping up. B, give me another name for line K. So we could say that is BC, because B and C are both on line K. Name a plane containing point A. Point A is over here. There's a reasonable level of assumption that you can do within geometry, where if it looks like it, you can probably go with it. The problem's going to be when we start hitting trig or right triangles, you guys will be like, it looks like a right triangle. Doesn't necessarily mean it. You have to kind of prove it. I will try my best to put on there, do not make assumptions about pictures, so that way you know when and when not to make assumptions. So the plane containing point A is plane M. All right, an example of 3 non-collinear points. You could pick any 3 you would really like. I'm going to pick 3 for sure that I know are nowhere on the same line. So I'm going to go C, D, and A, because they tend to be a little all over the place. Finally, E, the intersection of plane M and line K. So if you're looking, let me go over here so the projector is not painting me. I've got line K coming up through the center of this plane, almost like the pole in the basement that goes into the basement to hold it up so it doesn't fall. So where is that intersection between the pole and the base of your basement floor? And it's right here at point E. Now, my recommendation for you, because it's really hard for us teachers to time these things, is hit pause when I finish something before I go on so you have a chance to kind of copy it all down. The biggest recommendation I can give you is watch then copy, but it's hard to do timing when there aren't other people around. So we're just going to keep moving on. C. Now obviously, number 3, we've gotten to a much bigger, more complicated drawing. So you'll notice we've got a pyramid sitting on a flat plane. All right, so using that diagram, we need 3 coplanar points. So coplanar means on the same plane. Now when I do this, I like to view myself as not lazy, but efficient. So I know there's a bottom plane right here. I'm just going to pick 3 of those points that are on the bottom. So V, Y, and X. That is one option. Now, because this is a little bit difficult to visualize, I want you to imagine that this actually is a pyramid in front of you. And you're looking at that side. Those 3 vertices, those 3 points, are still coplanar because they make up the side to that pyramid. So I could say Z, X, and W as another option. All right. Part B, a plane containing point X. Well, the plane that contains point X, which is down here at the bottom, clean that up real quick, is going to be plane R. The intersection of plane R and ZVY. All right, so if you look, here is ZVY. And they're asking, where does that triangular plane meet with the ground? And it meets with the ground at line VY. Now, I'm going to say line segment and put dots on the end because this is a pyramid. Those lines don't go on forever and ever and ever. They have specific ending points. So your symbols that you use in geometry make all the difference in the world. Part D, how many planes do you see in this picture? So personally, I would say I see 5. 1 for the bottom, and then 4 for each of those sides to the pyramid. Now the reason it's not 6, and 6 is a really common misconception, is because the bottom of your pyramid is still on plane R. You do not consider them 2 different planes because they are one and the same. All right. 5, or E, how many planes contain point W? And I would say 3. All right, and here's my reasoning behind 3. Obviously, the bottom. Easiest one, boom, I'm done. Except I've also got this side to my triangle, and then I've got this side to my triangle. W, which is right here, is still on both of those side planes. All right. We're going to move on to number 4. I'm going to extend this so it's up a little higher and we can see. So 4 says, use the diagram at the right to answer the following. So we're right back to the same thing that we've been doing. A, what is the intersection of lines L and M? So if I'm looking at this, let me highlight a little bit. Ooh, purple pen. And Smartboard's going to be weird. All right, so M and L. Oh, it didn't give me purple. Give me purple. There we go. M and L. All right, where these 2 intersect is right here at point E. So, point E. All right, part B. Name another plane, or another name for plane Q. Now, I know this looks like a really stupid 2. It's a capital Q. It just looks funky because it's a script, and that's what you see right here. All right, so again, when you name a plane, if you're not going to use the fancy script, you need to use 3 non-collinear points. So if I'm feeling a little lazy, I know I have to include I because that's the only point that is not on line M. And then I'm just going to pick 2 of the points on line M. So we'll go I, F, and E. Part C. Are points D and E collinear or coplanar? So let me clean up my image real quick so we can kind of focus in on what we're looking at. Point D is over here, point E is over here. Now, I've got 2 planes, P and Q. However, any 2 points, really you need a third to create a plane. So because I'm just looking at these 2 points, I'm going to say collinear and not coplanar. And the reason for that is I don't have 3 points. I can't say they're coplanar unless I have a third point. So this is collinear. Finally, how many times do planes P and Q intersect? I would say they don't. They don't appear that they do. It appears like you're dealing with 2 walls in your bedroom that don't meet at an edge.